Alright, welcome back to another video, the third video on conics. Now we're going to be discussing ellipses. So what exactly is an ellipse? You know the sweet that you eat, you know the Eclipse sweet? Yeah, they have the same shape as an ellipse. So, coincidentally enough, both sound the same, right? An ellipse over here is just a stretched circle. So originally, if you have a circle like that, right, and then when you stretch it, it becomes an ellipse. But okay, you can stretch horizontally or you can stretch vertically, and this will also be an ellipse. Okay, so there's two ways, right? But note that over here is still the center, center, and the center. So the center doesn't change. So what is the general formula of an ellipse then, right? Recap the general formula of a circle. Typically, we use the standard form, so it will look something like this, right? But for an ellipse, it's slightly different. The ellipse general formula would be x minus h square over a square plus y minus k square, or okay, I'm just going to change this to k, y minus k square over b square equals to 1. So you can just remember it this way. I take the original circle, I adjust the x, right, the x plane, the horizontal plane by a units. So I adjust the x plane by a units, and I also adjust the y plane by b units. So I adjust both planes by a certain amount of units each. And note that this one over here no longer represents the radius, right? It no longer represents radius. It doesn't mean the radius anymore, right? What all that means is just nothing. It has to equal to 1 in order for it to be an ellipse. Okay, so now that I adjust by a units on the plane, from here to here is therefore a units. All right, from here to here is therefore a units, and then from here to here is therefore b units, right? Same thing here. A, B, B. So the height and the breadth, right, is no longer the same thing. Okay, or rather the height and the horizontal length and the vertical length and the horizontal length is no longer the same thing. Right? They are different things now, right? And it's all because they are adjusted by different scales. Now note that, okay, I'm just going to write here, note that if the a value is the same as the b value, we end up with x minus h square over a square plus y minus k square over a square equals to 1, right? And then we are able to then manipulate this over here to give us x minus h square plus y minus k square equals to a square, right? Which is back to a circle, right? It will collapse back to a circle. So it will collapse back to a circle, which makes sense, right? Because if, let's say, the two values here are the same, that means that the a value and the b value over here are the same, right? Because they're being stretched by the same amount of units. And since they're being stretched by the same amount of units, they will both have the same length, right? The horizontal length and the vertical length is the same, and therefore they will both collapse back into a circle. So it makes sense. Okay, so that is basically for this portion over here. So in order to tell whether it is this type of ellipse or this type of ellipse, you just need to ask yourself one question, right? Is the a value bigger or the b value bigger, right? So for this case over here, the a value is bigger than the b, right? And therefore it's stretched more wide, right? Or we can say it's wider, because the a value is just wider. But on the other hand, for this case over here, the b is bigger than the a, right? And therefore it's taller. Okay, that's a very intuitive way of remembering this. Okay, if not, that will be it for this portion over here under ellipse. And again, as what you expect, we are going to practice sketching this ellipse first now. And one more thing, right? Just now I mentioned just now, the center doesn't change. So therefore, these two portions over here, right? This h and this k over here, once again, the center is still h comma k. Okay, don't forget about that. All right, otherwise, that's it for ellipse. Feel free to pause this video now, try to sketch the curves, and once you're ready, you come back and resume and we'll sketch them together. Okay, so once again, everything can be done in your GC under your ellipse. Conics, right? Conics, then you, as in apps, then conics, then you key all your values inside and then it'll be able to sketch for you. But again, I want to show you how it's being derived so that, in any case, right? Let's say in the exam, let's say your GC, no battery whatsoever, you can still do the question. Okay, that's the most important thing. So A over here, x squared over 4 plus y squared over 9 equals to what? We'll rewrite this as x minus 0 squared over 2 square, y minus 0 square over 3 square equals to 1. So over here we can tell that the center is 0, 0, right? The A value, or the horizontal width, so the horizontal width is 2 units and the vertical width is 3 units. So since this is bigger than this, right, we'll expect this ellipse to be a bit taller. So if we were to sketch this whole ellipse out, yx over here, we know that the center is situated at the origin here, and it goes 3 units to the top and 3 units down, right? So it looks something like that, whereby here would be 0, 3, here would be a value of 0, -3, then here we'll have a value of -2, 0, and then here we'll have a value of 2, 0, right? Because, you know, the width here is 2 units, and then the height here is 3 units, and then from here to here is also 3 units, right? All in all, that would be it for this ellipse over here. Okay, so that's what you should have sketched if you did it correctly. Now we look at the other one, a slightly more complicated example, but nonetheless, it's the same principles as before. But first thing we note, this is that here is a 4, but we know that for an ellipse, this has to be 1. So let's divide the 4 over to the other side first. So we'll have 2x minus 4 square over, let me just, 9 times 4 plus 3 plus y square over 4 equals to 1. Then from here we get 2x minus 4 square over 36. Apologies, that was my WhatsApp. Let me just mute it. Alright, so that would be it. And then from here, we'll have 3 plus y square over 4 is 1. And then from here, we can see that the center, 2x minus 4 equals to 0. That means 2x is 4, and therefore x is 2, right? And then 3 plus y is 0. Oops, apologies. And therefore y is minus 3. So we know that the center is 2, -3. Now, this 36 over here can be written as, I mean, it's the same thing as just 6 square. And then this 4 over here is the same thing as just 2 square, right? So we know that the horizontal width is therefore 6 units, and the vertical width is therefore just 2 units, right? So in essence, we can sketch it out, and it looks something like this, yx. So the center is somewhere here. Yep, 2, -3, right? 2, -3 over here. And then when we sketch it out, the horizontal width is 6 units. So it will go all the way to here and all the way to here. And then the vertical width is 2 units. But here is -3, so that means it won't touch the x-axis. So I'm just trying to sketch it as accurately as I can. Probably looks something like this. Yeah, whereby here, this is 6 units, here to here is 2 units, here to here is 2 units, and then the center over there would be 2, -3, right? And that would be it for this. And then of course, best practice will be to always figure out what's the coordinates of your intercepts, which I'll find out now. So what I've done calculating, and I got that here is -1.5, sorry, 0, -1.51, -1.51, and then here is 0, -4.49 over here, right? And in case you're wondering how I actually got these coordinates, it's actually fairly straightforward. All I did was I sub x as 0 into this equation over here, right? And then I solve for the y value. That's it. Okay, if not, you will be able to sketch this graph pretty nicely, and that will be the end for ellipses. Let me know if you got any other questions in the comment section below. If not, I'll see you in the next video for the last shape, hyperbola.